This is Robert Sapolsky, and you're listening to Father-Offspring Interviews.
Hi there, welcome back to Father-Offspring Interviews. As many of you may have noticed, we had to take a week off due to some scheduling conflicts, but we are very glad to be returning for episode 60. And we are going to jump right into it. So Nicole asks, what causes Tourette syndrome? And is there a link to intrusive thoughts?
Well, Tourette's is one of the truly interesting, truly misunderstood, truly distorted ways in which the nervous system can go wrong. Lots of people know about Tourette's, which is the disease of scatology. People with Tourette's curse uncontrollably. That doesn't begin to scratch the surface. Most formally, it's a tic disorder where you have facial tics, you have arm tics, movement tics, things over that range. But what is characteristic of it is, in addition to merely ticking motoric, a lot of the Touretting tics have a strong emotional content, are something scatological, or something someone will shout out, something sexual, someone will make a barking animal sound, just a whole range of emotive explosions. So, in terms of making sense of it, right off the bat, if you want to get an incredible sort of description or picture of what Tourette's is presumably like inside the brain of somebody with it, look at this novel, Motherless Brooklyn, which is brilliant. And you get a sense of just the nonstop turmoil going on inside the head of someone with severe Tourette's, where they are ticking every 10, 15, 20 seconds or so. So Tourette's was named for Gilles de la Tourette, who was either a famous 19th century neurologist or a famous cursor. And what people began to recognize early on is there's a large overlap, about a 50% overlap with OCD. And this is interesting. OCD, obsessive compulsive disorders. Obsessive, you have thoughts going on in your head that you can't stop. Fears that you will do something blasphemous. Fears, thoughts. But also the C of OCD, compulsions, a drive to do certain motoric behaviors, make your utensils perfectly parallel before you can start eating, all the motoric rituals of OCD. So, in that regard, the compulsions, the motoric aspects of OCD have a large overlap with what you see in Tourette's. So, the question is this a version of having intrusive thoughts? And the answer here is no, in that the intrusive thoughts, that's the realm of the O of OCD, the obsessive thoughts, the obsessive fears that you're going to fail, the obsessive returning to sad thoughts, anxious thoughts. This is not the case with Tourette's. It's not the case with Tourette's that it's sort of your filter, your inhibitory filter has broken down so that you were saying things that you would normally suppress. It's not like that at all. These are fragmented bits of emotive communication. It's like you have hiccups of the id or something. We're just completely independent of what you're doing, saying so on. You're shouting out curses, you're barking, you're making an inappropriate sexual gesture with your hands. It's just going on like that in the background. It is not disinhibiting of, ooh, what all of us have going on inside us, but dare not ever say. Here you say it. No, completely different from that. So, what's going on in the brain? Predictable literature of studies making sense of it, looking at the brains of people who have died, who had Tourette's, and doing postmortem examinations. A whole realm of you putting in electrodes in different places in the brain, what's called deep brain stimulation, and seeing what areas there will provoke ticking behavior, what areas will suppress ticking in somebody with Tourette's. There's a literature on types of accidents that damage particular parts of the brain that produce tic disorders. But probably the most interesting thing is, of course, functional brain imaging, looking at the brains of people with Tourette's. And this ain't trivial to do because, as is sort of a starting point for doing brain imaging on someone, is they're lying in a brain scanner, they're staying still. And if you are having facial twitches, if you're shouting out stuff, if you're jerking your shoulder every 12 seconds, you're going to get all sorts of movement confounds in there. In addition, it's very hard to pick up anything with imaging related to auditory tics because anyone who's ever been in a brain scanner, it's like pounding away and making tons of noise. So it's tough to pick up whether this is happening. Nonetheless, there's been some progress with this, and there's two sort of broad themes going on with the neurobiology of Tourette's. And the first one is the most time-honored one. It makes perfect sense. And this was the work of Jonathan Mink in the 1990s, WashU, Washington University School of Medicine. And he was the first to sort of formalize what made a lot of sense, which is tics and Tourette's, as it's somewhere the intersection of emotive parts of the brain, the limbic system, and motoric parts. And not just any motoric parts, aha, I am now going to pick my hand up off the table, but reflexive, habitual, implicit stuff having to do with a part of the brain called the basal ganglia, and a subsection of it called the striatum. And his notion was that this is a whole network of motor cortex, striatum, sensory outposts like the thalamus, this whole circuit that you're normally using for habitual sort of reflexive behaviors, and the brake keeps slipping. Translate that into neuroscience. The inhibitory tone in this circuit is damped, is impaired. Translate that into neurochemistry, this neurotransmitter GABA, which is the most inhibitory neurotransmitter in the brain. And his notion was there's something insufficient about GABA signaling in the brains of people with Tourette's, in the brains of people in this particular sort of motoric circuit. And what people have seen in these postmortem studies is GABAergic neurons, the neurons that typically used GABA as inhibitory signal to tamp down the system. Some of these neurons are depleted post-mortem. There's thinning of some of the motor control areas. So this picture of just habitual movement stuff and the brake keeps slipping off because you've got a shortage of GABA. And supporting that, a number of hormones that interact with the GABA neurotransmitter system, obscure class of hormones called neurosteroids, they seem to modulate sensitivity in Tourette's. So there's this flavor of the brake is simply not working very well in this automatic, habitual, reflexive, motoric part of the brain. And what the brain imaging studies show is that's exactly what's activating during a tic, when you can actually like get reliable data control for the movement confounds. That's what's going on. But then there's a second theme coming through, and this is much more having to do with what's going on in the brain seconds before the tic. And as people with Tourette's describe it, as the urge, the impulse becomes just irrepressible as that builds up, and as always described, a burst of ticking, which releases this discomfort, which releases this built up energy. The period beforehand is characterized by overactivity of this completely non-intuitive to me circuit, what's often called the cognitive control network, the cognitive action network, the somatic cognitive action network, a bunch of premotor parts of the cortex getting ready for neurons to send messages to your muscles. That makes sense. But inputs from places like the insula cortex, veterans of this podcast will know we've talked about it before. Insula cort, adverse, unsettling, uncomfortable feelings, something with the anterior cingulate cortex, also a world of distressed feelings. And that seems to have something to do with the circuit of discomfort builds up, which is then released in this motoric pathway. And of course, the question becomes, what's wrong with the first pathway? What's wrong with the second? Why is it that building up of tension, and it's practically this hydraulic model that people with Tourette's talk about, the pressure builds, and then you tap the desktop a certain number of times and smack the side of your face a certain set number, and you're released. The pressure goes away for a while. How these two systems talk to each other. What sort of begins to give insight into that, which is it's not just, ooh, your motor system just like randomly hiccups now and then, but instead it's tied up with this built up tension and this urge and this discomfort that then gets released when the tics actually occur. What gives you insight into that is people with Tourette's tic a lot more, Tourette a lot more when they're tired, when they're stressed, when they're emotionally excited, to continue with this metaphor, with this uncomfortable hydraulic pressure on the system is built up even higher. It also has a cognitive component in there, in that if you make somebody who has Tourette talk about their tics, what it feels like, how they're feeling just before, it will trigger tics in them. So it's built up in introspection about the process, but emotional input and discomfort, which for some reason gets funneled into this pathway of motoric output. Now, one interesting thing is this somatic cognitive action network, this one of the discomfort building up. That's what dominates in the seconds before a tic. But one of the interesting findings in the field is it tends to continue during the tic itself, while that whole motoric system is activating. What's that about? It turns out for most people with Tourette's, doing one single tic doesn't release the pressure. It's got to be a whole sequence. So the urge, the being compelled, the discomfort is still there until you've completed this burst of these tics, so that this discomfort urge network is still going on early on in the process of actually ticking. So one additional component, so what's going on before, what's going on during, what's going on in people when they're trying to suppress their ticking, because this is socially stigmatized. People with Tourette's have all sorts of issues of being socially marginalized. It's a miserable disease to have, and a lot of people with Tourette's try to suppress their ticking. Oliver Sacks had a brilliant essay about one of his patients with Tourette's who had a conventional dead white male, white collar job Monday to Friday, and they were able, with a lot of energy and a lot of internal monitoring, to control their tics during their workday, and they would then explode into tics on the weekend. You could suppress it for a while. And the particularly interesting thing about that individual was, what did they do with this explosion of ticking on the weekend? They were a jazz musician, very acclaimed for their ability to improvise, and they're just random bubbling of emotive stuff that they've bottled up all week. What's going on in people with Tourette's when they're trying to suppress? And people familiar with everything we've talked about over and over and over could begin to guess prefrontal cortex is working hard at that point. Suppress it, suppress it. Hold off until you get home tonight. Hold off until this weekend. Hold off until you're in a place where tics are okay, where tics might even be rewarded, and suppress it in the realms where you would be marginalized. So we've got a different neurobiology of the pressure building up, the motoric, reflexive, with a flavor of emotions mixed in, hiccups of releasing the pressure, and then the efforts to try to control it in different social circumstances. So, of course, where does it come from? Not on the level of the neural circuits, but bigger picture, where's this disease coming from? A substantial percentage of cases, depending on which paper, half of cases or so are individuals who have a family history of Tourette's. In a lot of those cases, there's comorbidity with pretty serious OCD as well. And it's OCD dominated by the C, the compulsive behaviors, rather than by the obsessive thoughts. So that covers, I don't know, maybe half the literature. Where are the other cases coming from? And there's just one little interesting, irresistible, cool thread in this literature that was just beyond like interesting when it emerged and remains kind of controversial, which is a whole class of pediatric neurological, neuropsychological diseases. And here's the profile. This was first described by Susan Sweeto, a neurologist, National Institutes of Health, some years ago. This would be the profile. You get a kid, 2 years old, 4 years old, a young kid, and they get a case of strep infection. And it happens, they run a very high fever. Give them their medicine, antibiotics, it's fine, it goes away, they recover, everything's terrific. And then about 2 weeks later, this small subset of kids who had gotten strep explode into ticking behavior, just motoric tics that have elements of OCD, and it just pours into this. And at least in her initial studies, it suggested a lot of people with Tourette's, a lot, 25%, I don't know, I'm winging it here, certainly not a majority, but enough of a minority to make this interesting, had a history of their tics starting a few weeks after a strep infection. What's that about? And the model that was presented, for which there's evidence in other neurological diseases, is you run a high fever and you've got this thing in your brain called the blood-brain barrier, which is basically wrapping around every blood vessel in there because your brain is working 10 times harder than any other organ to make sure stuff in the bloodstream that should not be getting into the brain doesn't get into the brain. A really high-powered filtering system. And what is seen is high temperature, high fever opens up the blood-brain barrier. When you get very hot, when you run a high fever, that could begin to open up the blood-brain barrier. And what happens then in this scenario is circulating white blood cells from your immune system, whose job it is to tell the difference between you and invasive pathogens, suddenly get into the brain because the blood-brain barrier is loosened up. They get in there and they don't know from the cerebellum, they don't know from the hypothalamus. All of this is strange alien stuff. And they begin to form antibodies attacking elements of your central nervous system. And thus you have an autoimmune disease. And the model that was presented was in these cases of strep, subset of kids, blood-brain barrier opens up, immune system, immune cells get in and begin to develop antibodies against exactly those inhibitory GABA neurons in the striatum and begin to damage them. And from there, you get a Tourette syndrome. So the first evidence that came in was seeing a higher than expected rate of people with Tourette's had antibodies in their bloodstream against elements of their nervous system. And this was totally exciting and gave rise to this irresistible acronym to describe these PANDAS diseases. PANDAS, like many pandas. PANDAS, pediatric autoimmune neuropsychological disorder associated with streptococcus. And that was the scenario. And in that realm, what you would predict is if you immune suppress the individual, you damp down the crazed autoimmunity, and that should be protective. Evidence for this began to trickle in, but in the years since, the jury is still out on whether PANDAS is indeed like a disease entity and whether that is ever sometimes frequently a gateway to Tourette's, and that remains controversial in the field. And people in it have come up with endless new acronyms to try to fine tune some of the elements of it that are or aren't matching the data. But there is one precedent for that in the literature, and this one is solid, a disease called Sydenham's chorea. Chorea, like choreography, whole body. This is a disorder of kids who have had a strep infection. It's a group A strep infection for strep fans, and high fever, open up the blood-brain barrier, and antibodies are formed against another element of the motoric system. And this is somebody who gets uncontrolled limb movements, choreic movements, and this was traditionally called Saint Vitus's dance. And what you see with sydenham is the antibodies are there. It's reasonably well characterized. You give the individual immune suppressants, and that will get the symptoms to go away. Unfortunately, in most individuals, it disappears after 3, 6 months or so. So there's at least one precedent for high fever lets your immune system get in there and start attacking motor systems so that you just tick uncontrollably. Again, that's controversial. I love that theory. I repeat it indiscriminately to anyone who will listen, but the jury really is still out. But that is perhaps a subset of Tourette's cases. Again, about half are genetic, and it's built around not just motoric tics, but an emotive urge, a drive, a pressure that builds up that's sensitive to stress, sensitive to fatigue, sensitive to all sorts of, where finally doing this motoric thing, shouting out that sound, quacking like a duck, releases the pressure for a while.
All right, next, Ebe from Mauritania says, I don't think I still believe in free will. Nevertheless, I still do believe in a God. What do you think would become of religious beliefs if people were to start believing less and less in free will? Do you think we would see the emergence of new beliefs or modifications, or would religions just cease to exist?
Well, fantastic question from a fantastic place, Ebe. I've never heard from anybody before in Mauritania. It's a place I've always wanted to go see. In fact, I always thought one day, this is unlikely to happen, that I would hike the length of Mali and Mauritania. So it's very good to hear from you. It's very interesting to hear what you're struggling with, in that a priori, it seems as if there's something connected between whether or not you believe in free will and whether or not you believe there is a God or gods. But in actuality, they're two separate axes. And you can produce sort of a 2 by 2 box with it. You can have people who are atheists, there is no God, but there is such a thing as free will, and that's your typical atheist. You could be an atheist, and I also don't believe there's free will. That happens to be the category I fall into. You could be the most common, which is believing there is a God and there is free will. But then the fourth box, the one you're alluding to, is I don't think there's free will, but I believe there's a God. And your question is, if people move in this direction, is this going to produce new types of religious beliefs? And the interesting thing is, this concept has already been there for centuries, many centuries, the notion that there is a God and there is no free will. And this takes the form of sort of the Christian notion of predestination, this whole notion that God knows everything that is going to happen. God has already made judgments for things that are going to happen in the future. This is a very Christian theology, and Ebe, I'm assuming you're Muslim, given that everybody in Mauritania is. So this is pretty alien terrain for me as well, but it's mostly associated with this 15th century Christian theologian Calvin, Calvin in Switzerland, France, who the father of Calvinism, who was very, very instrumental in sort of purifying this notion of predeterminism. God already knows who is going to do things to make them worthy of salvation, who is worthy of damnation. God already knows this, and this puts you in a very interesting position in that, in effect, you do have free will to do whatever you want, but you don't have any control over doing something that's going to get you either salvation or damnation. So it's kind of a halfway version of not having free will amid there being a deity. And this is where things really went off the rails for me trying to read about this, because there's a difference between whether God knows what's going to happen or God controls what's going to happen, and whether this is God knowing about individuals or groups. And before you know it, I could not believe the terminology for this medieval theorizing. And this is finally medieval in a literal sense about how this stuff works. There's conditional election of by God of somebody where they're good. There's unconditional. There's lapsarian. There's prelapsarian. There's antilapsarian. There's superlapsarian. All these different schools of thought. There's versions where God only knows who's going to get saved. There's versions where God knows both who's going to get saved and who's going to get. So theologians spent a long time sort of dissecting this back when. The main point being there is a rich tradition, and apparently not just with Christianity, but sort of most developed there, of people finding a way to simultaneously believe all of our actions are predetermined, and yet there is a God, parentheses, and where it's okay that we are ultimately judged by that God. So some people manage to pull that off.
Finally, Ina from Russia/Lithuania says, I'm interested in the discrepancy between human sexual maturation. For example, in girls, it might come at the age of 12 to 15, whereas our PFC fully matures only roughly by the age of 25. Was it good for human evolution that a girl without enough social and cultural experience in the middle of the period when she was prone to her most risky behavior and sharp mood swings could become a mother? And not only could she become a mother, but according to David Buss, Evolution of Desire, adolescence was the most fertile period in a woman's life. And how does it go in other primates?
Well, this is very interestingly tapping into a weird thing about humans and human brain maturation, which is, by the time you're hitting puberty, the part of your brain that is most pickled in emotion, in anticipation, in desire. Shorthand for us right now, areas making heavy use of dopamine as a neurotransmitter. That whole world is pretty close to being up to adult speed. Adult drives, adult desires, adults, anticipation of pleasures and such, coupled with the other like key fact about human brain development, which is the prefrontal cortex back from just a few minutes ago, regulating thought, emotional regulation, prefrontal cortex, which is not fully up to speed until you're about 25 years old. So we have this gigantic yawning chasm that we call adolescence or adolescent behavior, where the emotive that drives the urges are going at something close to full speed, and the self-control is still limping along with like barely 3 neurons functioning. So the question is, what's that about? What to make of the fact that humans have developed this? So the first question is looking at when the drive, the emotions, the desire, the urges come on around puberty. Where does that fit in with other primates? And it occurs at roughly the same time proportionally in terms of percentage of lifespan as with other primates. We hit puberty at a very like typical primate point. What's distinctive about us is the delayed frontal cortical maturation. And that is much, much more extreme in humans than in other primates. All of them have somewhat more of a delay than you would see in guinea pigs. But by the time you get to humans, it's a very dramatic delay. So what you have is this great lag time where the time of life where somebody has their strongest reproductive urges, they have their least self-control, and thus the highest likelihood of getting pregnant. What do we make of that? So there's one style of approaching this, and this has been discussed in another context many episodes ago, this field of social biology, an adaptationist approach, which is to say, oh, well, in humans, there's this big lag between emotive, endocrine, hormonal, horny maturation, and self regulation. So it must be there for a good reason. It must be there for a good reason. And the idea sort of being suggested here is, whoa, that's the time of life where disinhibited sexual behavior is most likely to get you pregnant and pass on copies of your genes. Ah, that's adaptive. That's great. Having that lag period of being disinhibited like that without any brakes working, that's a great way to pass on copies of your genes. This would be a very adaptationist. There's got to be some reason. Let's come up with a story. I'm not terribly impressed with this story. First off, it turns out early in adolescence, fertility is a lot less than people used to appreciate. Girls, for example, when they hit puberty, typically it's about a 3 year lag between when they first start getting periods and when they start actually ovulating. That's about the 50% cutoff point. So there's a big lag with that. And David Buss, the book you refer to, which was a wonderful book from the early 1990s, he has since sort of revised his estimates based on more current research, and it seems like peak human fertility is more like in the early 20s. Nonetheless, we still have this problem of peak fertility while emotive, anticipatory urge stuff is going full blast and the prefrontal cortex is not fully up to speed yet. Is this just this great strategy of saying, what a great time to take advantage of this gap, this dissociation, and leave lots of copies of your genes? I think that is not likely to really be the driving force on the system. For one thing, the younger someone is, the lower the average birth weight of the child they give birth to. And that's actually an inverted U. Very young mothers, very old mothers give birth to kids of lower birth weight. The younger you are, the more likely there are to have perinatal complications, the more likely you are, the mother attempting to deliver at age 14 or something, the more likely you are to die in the process, the more likely long-term health consequences for the kid. This is not such a great idea. It's not a great evolutionary strategy to have humans in their most horny but least regulated stage be their most fertile. So, what's this doing here? And this brings us back to a concept we've hit on a number of times. I think this reproductive consequence of delayed frontal cortical maturation, I think this qualifies as a spandrel. It wasn't selected for this. We were not selected for to have our greatest sexual appetites and most imprudent judgments at the time when we are most fertile, because that's a great way to leave more copies of genes. Because there's lots of reasons of thinking you don't do that. That's actually not terribly adaptive. It's just something that occurs for a different reason. And I think this has something to do with the complexity of human social relations. What's the frontal cortex, prefrontal cortex doing? In a soundbite, it makes you do the right thing, even if doing the right thing is really hard to do. Self-control, gratification postponement, long-term planning, impulse control, all it makes you do the right thing when that's a hard thing to do. And I think the reason why we're not fully up to speed with that until we're 25 years old, which is if you're a chimp, if you're a baboon, if you're a lemur, if you're lots of other species, there's a very limited number of behaviors, and what counts as doing the right thing can be fairly finite. With humans, it takes us a long time to learn what counts as doing the right thing in this circumstance. For one reason, because we're a species that functions with hypocrisy and lies and double standards, and do as I say, not as I do, and all these ways in which you learn, well, thou shalt not kill, but if you kill this sort of person, we'll give you a medal. Or this is a circumstance, never, you do not lie, but if somebody's demanding to know if you're keeping refugees in your basement, then you lie. It takes a lot of complexity to learn what counts as doing the right thing in different human cultures. It is a very, very complex task. And it is not just a cynical one of, ooh, so we could learn where the hypocrisies are in our own particular culture. What counts as doing the right thing is a very, very complicated thing when you got as socially complex of a species as we are, and you sure are not going to program that into genes driving prefrontal cortical maturation. If the prefrontal cortex is the last part of the brain to fully mature, by definition, it's the part of the brain that is least shaped by genes and most shaped by experience and environment and social context. And that's a great thing because it ain't easy to learn what's the right thing in a circumstance. So I think that's been the driving evolutionary force on the delayed frontal cortical maturation and this world of hideously disinhibited dumbass teenage things that occur is just a byproduct of it as a spandrel rather than the thing that was selected for, because my guess is it's mostly selected against.
And that is it for episode 60. Keep submitting questions at the form found in the Instagram story highlight and bio or the YouTube video description. I'm Offspring Share Sapolsky, and thanks for your continued support of Science and the Beard.